Okay, math fans, let's get started. We're going to begin our chapter 4, section 2 with experiments, and so let's talk about that. There's a lot of objectives in this chapter, so I want to make sure that we spend enough time going over everything, so we're going to spend 4 days going over all of this. The first thing I want to talk about is the difference between an observational study and an experiment. The big, major difference is going to be this word right here. If you cannot find a treatment, it is not going to be an experiment. Otherwise, it will be an observational study. And all an observational study is you're just observing individuals. You might measure a variable here and there, but it doesn't really impose a treatment. It doesn't control for any other variables. And that's just what it is. It's an observational study. Experiments will always have a treatment, and we'll talk more specifically how a random assignment of treatment really defines a well-designed experiment. So here's my classroom, and it's not really my classroom, but let's pretend that this is my classroom, and I want to see whether or not, I wonder what would happen if on the next test I decided to set the temperature. The temperature's normally set at 72 degrees. And I wanted to, and I got, let's say I gave an exam and I got all the test scores back, and I got an average score of 85%. Okay. And then I decided to raise the temperature. I'm going to raise it to 82 degrees on the next chapter test. And my average score is now only an 80%. Can I therefore conclude that raising the classroom temperature will decrease my average percentage score on my chapter exams? And the answer is no. Okay? And the real main idea behind this is that there are so many other things that could have caused the class average to go from 85 to 80%. It could be, it's a different test. I gave chapter 1 on the first time and then chapter 2 the second time. Maybe chapter 2 is more difficult. Perhaps I gave this during different periods. Perhaps, the kids didn't get a good night's sleep the second time around. There's so many other things that could explain. We're trying to figure out what could explain the switch from 85% to 80%. Yeah, I'm observing that the temperature went down, but that's all it is. It's an observation. I'm just observing this, and I'm measuring their test scores, and this is not an experiment. This would be an observational study. That leads us to this definition of confounding. Confounding occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So, a couple vocabulary words I really want you to get down. One is called the explanatory variable, and the other one is called the response variable. And the explanatory variable is just that. It does the explaining. The explanatory variable in my classroom example is the temperature, the classroom temperature, and the response is how well the kids are scoring on the test. Now, there's something else that could be causing the response variable, and we don't know what it is. It could be a number of things, and I listed them off, and we call that confounding. Take a moment to read this example right here. Go ahead and pause the video, read through it, and we'll talk about it. Okay, now that you've read through this, you can tell it's an observational study because it could be due to so many other things. There's so many confounding variables that we're not controlled for. And so this is definitely an observational study. and we could just leave it at that. Experiments show a cause and effect relationship only. It seems like there's always a different article about coffee. It's good for you, it's bad for you. Take a moment, read through this, pause the video, and we'll talk about it. Again, this is an observational study because we don't know if drinking coffee is really the cause of a longer life. It could be something else. There's still those confounding variables out there that we don't know. The way the study was done, it's just an observational study. Not that the information is not valuable. It's not an experiment. It doesn't show a cause and effect relationship. Here's some vocabulary for you for the language of experiments. Please pause the video again. Make sure you have these vocabulary words down, especially a treatment. It's a specific condition applied to individuals. And then, of course, the experimental units, they will ask you on an AP test, given this experiment, what are the experimental units? And when they're human beings, we call them subjects. So just be familiar with these vocabulary terms. Here's another example. Researchers studied 812 people in 376 households, and they gave them a couple of different treatments. And so they wanted to know what are the experimental units, the explanatory and response variables, and the treatments in this experiment. Take a moment, try and answer this based off the reading, and I'll show you on the next slide what the answer is. This one's kind of tricky. The experimental units are actually the households, not the 812 people. A lot of people will get this wrong because they immediately gravitate towards the people. However, it was the households that got the treatment, okay? One of these treatments here. These words that I can barely pronounce. But it wasn't the people that got the treatment. It was the households that randomly got assigned the treatment. So actually the experimental units are the 376 households, not the 812 people within the households. So yeah, that experimental unit is the smallest unit that gets the treatment. The explanatory variable is the type of medication. And then the response variable is whether or not they were lice-free. Does adding fertilizer affect the productivity of tomato plants? Read through this example and we'll go over the answer to this one. Go ahead and pause the video. Again, it asked us to identify the experimental units or the subjects, the explanatory, response variable, and the treatments. Okay, so the experimental units are the tomato plants because that's what's getting the treatment. So there's two explanatory variables. One is the fertilizer and the other is the amount of water. So you can have more than one explanatory variable. Now, a combination of those explanatory variables is then called a treatment, okay? So the response variable is obviously going to be like the weight of the tomato after we apply the treatments. And so there was actually 6 treatments. Okay, the reason why there's 6 treatments is because there were 6 different possible combinations you could have had. First one, fertilizer, ½ gallon. Second one, fertilizer, 1 gallon. Third one, fertilizer, 1.5 gallons. And then no fertilizer, 0.5, no fertilizer, 1 gallon, no fertilizer, 1.5 gallon. There was actually 6 treatments there. And that's going to do it for day 4. We'll see you in class.